Gary is a senior, he's the president of the ISSS and a senior expert systems engineer at Airbus Defence and Space that develops a range of military aircraft, combat aircraft, and other. It's I think Airbus Defence is involved in modernizing India's defense system also and developing a good defense manufacturing ecosystem. Um, Gary has worked in multiple sectors, and starting with industrial chemistry, relational database systems, telecommunications infrastructure, and now in the defense and space sector. And I think this definitely gives Gary the experience across sectors to develop unique insights into the complexities of system science. I must mention one of his landmark publications is on architectural parallels between biological and engineered solutions in defense and security. Gary has applied system science thinking to cancer and other diseases, and today in his presentation he will be discussing very importantly the definition of systems and the principles of sustainable system design, and importantly, connect systems theory to sustainability, resilience, and regeneration. Again, very important when considering the stage that we are going through, the entire globe is going through. He will analyze the current condition of the current global human social system and discuss its limitations and propose a way to a sustainable future. So, Gary, without wasting any more time, I would invite you to make your presentation. Thank you so much.
Thank you very much for the invitation today. I do really appreciate it. So yes, I'm going to be talking about architecting sustainable systems, but I'm also going to be providing, I'd say, some rich context for that as well. I'm going to be referring to a lot of material which I've kind of brought together into this overall system, if you like, and I'd like to start off first of all with this delightful book by Daniel Christian Wahl, Designing Regenerative Cultures, which is a splendid book and I can recommend it. And in that he says that a regenerative human culture is healthy, resilient and adaptable. It cares for the planet and it cares for life in the awareness that this is the most effective way to create a thriving future for all of humanity. The concept of resilience is closely related to health, as it describes the ability to recover basic vital functions and bounce back from any kind of temporary breakdown or crisis. When we aim for sustainability from a system perspective, we are trying to sustain the pattern that connects and strengthens the whole system. So sustainability is first and foremost about systemic health and resilience at different scales, from local to regional to global. And I'll be looking at those different patterns, local, regional, and global, in the talk. The other thing I'll talk about a little bit is, what is system as a concept? Because there are many definitions which have been offered. They all include a common core notion, but vary in many respects. And system is an extremely general concept with an enormous number of specializations and instantiations. So definition is a great challenge. There is, let's say, no shared definition or understanding of what system is, but it's an incredibly important term. And I'm going to be recognizing Tom Maslov in some of this work, which I know that Bruce McNaughton has also been working on. So when we look at all of these different definitions of systems, and this is just a few, there are many, many, many from many wise and knowledgeable people. But what Tom has done is he's looked at almost like a hierarchy of systems definitions. And starting at the top, we have, let's say, the most loosely constrained definition. You know, system A, it's just a point of view. Yeah, it's a way of looking at the world. Yeah. And this lines up with something that Weinberg was saying. But as we go down through these different levels of hierarchy, what is happening is we're adding more and more constraints to the term. So eventually we get down to, you know, system G, which is structurally coupled with its environment. So we go down through, it's simply a collection, it's a collection of two or more parts, it forms a whole, novel property emerges, the system cannot be divided. And I think from the perspective of appreciation of systems, this most rich definition, which includes is a part of the whole, is really important in the context of the environment. All systems are deeply connected with their environment. And if you take a system out of its environment and put it into another environment, it's actually another system. I'm going to talk a little bit about system science, but not too much. So the let's say the concept of system science is that it is a set of concepts, theories, principles which are transversal across everything, because essentially everything potentially in the system is in the universe is a system. It's everything in the universe is an organized whole, and also a part of something greater. Yeah. And I'll mention just a few things that I really appreciate. So there was a scientist, Len Troncali, who's been working on essentially system science and general systems theory for many years. And one of the things that he's identified is this universal pattern of integration, emergence of new wholes, diversification, integration, emergence, etc. So this pattern is really interesting. And what we also see is the implementation of that pattern as we go up through essentially the nature of systems in the universe, going up from quanta through nucleons to nuclei to atoms, molecules, cells, multicellular organisms, social groups, etc., etc. And this comes from Tyler Volk's grand sequence and his book Quarks to Culture. And what's interesting is you go up through these different levels, the levels become increasingly rich in terms of information and also complexity. And of course, this relates closely to our established sciences like physics, chemistry, biology, and we can see the different relationships and interactions which take place as we go up through the schema, and as we approach sociology, physiology, and politics, economics. We're now talking about relationships through information and power structures, through money, resources, and services. I also like to mention George Mobus's work on general systems ontology, which is covered in some of his books. And these are terms, example terms, which are, again, universal to all systems. So all systems have components, they have behavior, there are processes that are taking place, and as I say, they're coupled with their environment, which provides context and also meaning. Another really interesting conversation that I've had is with Hilary Saletto, who's a systems engineer and an architect. And as part of this overall pattern, he's recognized this schema, which is in that schema, the members, the parts are constrained by the whole, but the members also get benefits collectively by participating in that whole. Um, Systems have emergent properties and also affordances for new relationships. So you can use this schema to look at any kind of system and think about the members and what are the constraints, the forces that are holding them in place, the benefits that those members get. At the very lowest level, it's about essentially stability. And you can look at the emergent properties and the relationships which come from those systems. And I've used that in thinking about again those levels that Tyler Volk identified. And at the higher level, we're talking about agri-villages as a system type are formed from the combination of plants and animals and also cultural meta-groups, and these come together to create agro-villages. So the distinction with agro-villages as opposed to cultural meta-groups is that we're now putting roots in a particular locale. So this is the constraints. The benefits for the members are mutual life support. And as a result of agro-villages coming together, the emergent property is agriculture, and the affordance for new relationship is crops, because agro-villages can relate to other agro-villages and crops can be exchanged. Now, agro-villages come together through what Tyler calls a process of combogenesis. So things of a prior level coming to make things of a higher level, a new level of order, if you like. And now we have geopolitical states. So agro-villages come together to create a greater collective. And now we have regions, we have emerging higher level transversal organizations. And at this next level, we have the constraints on the agro-villages is laws and customs which apply across the whole of the culture. The benefits for the agro-villages is hope and security. The emergent property is command and control, and the affordance for relationships is now war and peace across geopolitical states. So this is an interesting way of looking at this emergence of new levels. And what's also interesting is when you look at these different levels, there are technology subsystems which we've developed within those contexts. So at the level of agro-villages, we've been developing things like wind and water mills, blacksmiths, grain stores, and these all provide their own let's say conditions related to the 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 affordance for new relationships, the emergent properties, etc., etc. And at this level of geopolitical states, we've now got emergent subsystems like cities and currency, infrastructure, industry. So it's an interesting way of using that framing to try and get a almost like an holistic understanding of what's happening at each of the different levels. So all of this is providing some context for what is happening at this particular point in time, and some of you may be familiar with the limits to growth, um, which was quite a famous model looking at essentially plotting the potential future of let's say happenings on this planet. And we're going through an area around this area at the moment. So potentially we're heading towards a poly crisis, and you can see lots of rapid changes in things like pollution, food per capita, services, births, deaths, and you can see this massive decline in resources, which we are starting to experience. And there was a talk at the ISSS by Charles in September 2021, and he was reflecting on, is the limits to growth model still valid? And he was confirming in his talk that pretty much what was predicted is where we are in this current state of affairs. So there is rapid change on the go at the moment. And as you know, we have the the changes in terms of the environment and climate as well, which is all part of that pattern that we were looking at on the previous slide. And you know, I'd just like to emphasize the point that beyond 1.5%, 1.5 degree change in our Earth environment, we get a massive change in terms of impact on the planet. And I talked about that model, the limits to growth and the changes in resources, the massive decline in resources, and when we look at this peak of, the human eco footprint versus the time duration of civilization, um, we are pretty much approaching the top of this peak. Um, and that has an impact on the carrying capacity of the planet. We're in overshoot at the moment, which means that we're exceeding essentially the resources that the planet can offer us. And as a result of that, essentially debt that we're taking out, we are reducing the potential carrying capacity of the planet. And this is from this publication here. So we've got two choices really when we're at this kind of level. We can either start preparing for and changing our behavior and looking at essentially a soft landing, which might look something like this, or we could continue in our existing behavior and end up with something which would look much more like a total systems collapse. So this is just you know one portrayal of the future, which is very important for us to start thinking about, and not just thinking about, but actually doing something about changing our behavior on the planet, because we are exceeding the carrying capacity of the Earth at the moment. Now, sustainability depends on the intelligence of the system to respond to changes in environment. And from what we're observing, with, for instance, the activities that we're seeing in the COP, we're not seeing any change. We've been having our COP meetings since 1995, and essentially it's had absolutely no impact on the trajectory of our response to the environment. So, even with, and this is from a publication a few years ago, even from a few years ago, looking at, what was actually happening, our ability to achieve the 1.5 pathway has essentially been already exceeded. And if we continue in our current policies, we're going to be looking at a global climate change of a rise of 2.5 to 2.9 degrees centigrade, which would have an absolutely massive impact on our environment and our ability to live successfully on this planet. So, from the perspective of intelligence, we're really not very intelligent, because we're not using our know-how to change our behavior. So when we now look back at the model I was showing, which is our current global human social system, when we look at the systems that are in place, both at the local and the geopolitical level, we have these kind of technology subsystems which are at place at the local level and the global. So we have social media now, on-demand consumption, Internet of Things, big data. At the higher level, we've got mega cities, multinational corporations, the 1%, and of course we have a global economy now. Everything is connected. Now, when we look at the dysfunction which is taking place at these different levels, we are seeing a global decline in biodiversity. In our agri-villages, we have monocultures, we have fragility, poverty for the many, and unfair trade. And these are big generalizations. When we look at individual areas, we can see that there are improvements already taking place. A movement to regenerative agricultures, for instance. But these are still isolated areas. But what's interesting is we do have the technology, we do have the know-how to change these things. When we go up to the geopolitical states, we're looking at, uncontrolled growth, subjugation, convenience, debt and profit. But the overall picture is, we have unsustained growth, climate change, mass extinction, pollution, and toxins. So we really do need to change. And what I'm showing here is a rebalancing. What could we be doing? What would a better future look like? So here we've got rewilding the wild, resiliency, regenerative roots, culture, sustainable cooperation, meaningful purpose, a change in life values, emerging global consciousness, uh, accountabilities for our leadership. Um, so, over this way, we're looking at some of the potential technologies, the subsystems we could be creating, savings and surplus management, community markets, more local, shared local services, repairing and conserving rather than producing products and throwing them away. Potentially at this higher level, a United Earth Federation, system and complexity science as a new science to help us with, the systems perspective, augmented intelligence, taking advantage of AI in a good way, and better democracies, which are based on facts and knowledge and thinking, rather than some of the the political changes we've been seeing in the current years. Yeah. So, just to reinforce again, here's another piece of work which I thought was really nice. Sustainability is not possible. We're so far deeply in the red. We are far beyond sustainable, and we need to be thinking about restorative and regenerative, living systems, more consciousness, doing the right things. So this is where we need to be heading. Sustainability is not enough because what we have at the moment is not sustainable. So I'm going to be looking now at some of the architectural aspects, and again, drawing on a number of different patterns and works from various areas. But I'm going to be drawing again on that concept of holarchy. You know, everything is an organized whole, but a part of something greater. And I'm going to be gradually going up through these different levels of systems. We've got systems at the technology level, at the system of systems level, at our organizational level, at the human activity level, the level of enterprises and businesses and missions, the international and national level, and then at the highest level, at least for this talk, Earth as one living planet. And as we go up, at every single one of these levels, we have functions and physicalities and qualities which are related to those different levels of the holarchy. And at every level, from an understanding of these, we can derive requirements. So requirements for the living planet, requirements at the international national level, etc., etc. And I can draw on these existing patterns to help give us some guidance in the kind of things that we should be doing at each of these different levels. So I'm just going to be making that explicit. So if we look at the Earth level, we know that we're exceeding planetary boundaries. But here's something that came from this particular group, the coming Montreal Global Diversity Framework, which I think is really nice. I won't go into all of the details, but I provide the reference for all of this material in the talk. So we're looking at conservation, avoidance, safeguarding, and acting. You know, and you've got these things that are being suggested that we should be doing. Sustainably managing and using wild species, for instance, sustainable agriculture, fishery, forestry, restore and enhance nature's goods, services, increase area quality of urban, green, blue spaces, a fair sharing of benefits from genetic resources. So these kind of principles should be utilized to help to direct global policies. At the international level, of course, we've got the SDGs, and this has been organised in terms of impact on the biosphere, society, economy, and again, this this work here provides some nice patterns on some of the things that we should be taking into consideration. So this is what's at play at the international level. At the enterprise business level, for organizations, for instance, like Airbus Defence and Space and other large corporations, we should be taking into account something like this really nice diagram, which is, designed for sustainability, looking at design for resources, design for environmental impact, design for recyclability, remanufacturability, design for social, design for functionality, design for manufacturability. So these are all qualities which we should be taking into account when we're acting at the business level. When we're working within those businesses, businesses are made up of organizations. And again, here's some really nice guidance on what we should be doing at an organizational level, enhancing the well-being of our workforce, ensuring our infrastructure and operations are resilient to climate change, creating an ethical and resource efficient supply chain, reducing the environmental impact of our estates. Our manufacturing facilities should be more in tune with their environment, minimizing the health and impact of travel. So these kind of things should be taken into account at an organizational level. Now we start to come into systems of systems. So we have design processes, design principles, design methods. And when we look at the principles level, maintaining focus on fundamental design outcomes, learning from nature, applying systems thinking. So again, lots of useful things to think about at the systems of systems level. Another nice piece of work looking at product systems and how products and the manufacturing system itself could be more environmentally conscious and supporting sustainability and regeneration. So, again, looking at all of these different patterns, which can be taken into account when you're thinking about, the development and delivery of your products, the manufacturing product process, the product materials you use, your packaging, using less resources, um, having a positive impact on climate activities. Product impact, is eco-friendly. The transportation, the supply chain, short supply chain. So doing things more locally, reducing the risk of having unsold inventory. All of these things can have an impact, from an environmental perspective. So I'd now like to draw on some of the work from Amar, who has very, very kindly invited me to give this talk. So in this particular publication, and this was actually an inspiration, this was part of the inspiration for giving the talk, I must admit. So when we look at these 8 factors, dimensions of an ecological system, we can see it's made up in terms of ecology, relationships, institutions, governance, agriculture, services, processing, manufacturing, and organization. And you can see some of the relationships of these things with that hierarchy that I was just going through and some of the principles which are shown from those of the works. Now, what Amar has done in this publication is he's identified for each of these topics a number of, let's say, key performance indicators, if you like. And over on the left-hand side of the diagram, you can see indicators which are indicating non-healthy things, which are, let's say, not systemic or anti-systemic. And what we have on the right-hand side are things that are contributing to health and are promoting, systemic activities, systemic outcomes. So we've got essentially things that are pushing towards unhealthy situations, and on the right-hand side we have things which are pointing towards healthy situations. And this is a useful framework for our activities in those ecosystem spaces, moving towards regenerative situations. So I won't go into the details of how all of this was derived, but I've been working on something which I call a general human activity system, which is based on essentially relational holarchy. And what I'm doing here is I'm making explicit non-systemic pathways that promote pathologies in the human activity system. Now, what we have here is essentially four quadrants, and these quadrants relate to let's say an overall cycle. So the cycle is essentially building relationships, building knowledge and perspectives, activities, and working out new ways of doing things. And what we have here is essentially the living systems that are created through our activities. There are nine motivations which form part of this model. So there's spirit, living, philosophy, and theory, technical, action, intention, decisions, design aesthetics, social, and political. For those of you who might be aware, there is a general pattern going on here. One instantiation of that pattern is something called OODA. It's observe, orient, decide, and act. And this general human activity system is an instantiation of that. So we have orientation, sorry, we have observing, orienting, deciding, and acting. What we have here in terms of the clouds are what we're calling general system pathologies. And this came out of a workshop that we did in the IEEE about 5 or 6 years ago. So the pathologies we see in our human activity system, these are general to all of our systems. Isolation, pain, sadness, no vision of the future situation, perspective gaps, confusion and complexity, not seeing the connection flow of causality, limited choices. These are all of the pathologies that we see in our daily lives, in the work that we do in our social systems, in our organizations. And one of the jobs of systems people, for instance, is to help to resolve these pathologies and to help mitigate these negative pathways which are identified with the red arrows. And these are motivational powers, and these motivational powers can be used for both good or evil, health or dysfunction. Now when we look at the political center, for instance, and these are negative pathways which are, let's say, anti-systemic. So here we've got a pathway which is a reluctance to change to retain the establishment, and this blocks no vision of the future situation. We have manipulation of information, hiding, downplaying the consequences, which helps to promote the pathology of not seeing the connection flow of causality. Here we have a pathway, benefits for the parts and not the whole, which is essentially corruption, which is taking us in the wrong direction. And here we have the manipulation of relationships, blaming the other, and this contributes to a lack of information, knowledge, and appreciation. So, this is just making explicit the negative pathways which take us in unhealthy directions in our societies and in our workplaces. Now, as well as the negative pathways, we have, of course, the positive pathways, the systemic pathways that help to resolve the pathologies in the human activity systems. The drivers for change remain these nine what I call transformational powers. This takes into account that some really excellent work from Bill Smith, one of the contributors to the IEEE. And these nine transformational powers all came out of his PhD and his experience with working with the World Bank. So now we're looking at the positive pathways, and these positive pathways help to resolve the pathologies and to make things clear, for instance. So again, when we look at the center, as an example, we have a pathway of giving voice to future possibilities, which helps to address no vision of the future situation. Planning ahead, which helps to resolve the pathway of not seeing the connection flow of causality. The wrong direction is addressed by taking ownership of issues, and resolving this lack of information, knowledge, and appreciation. We have engaging with stakeholders. So I've just highlighted some of the pathways, both forward and negative. And what's interesting in our society systems, these forward and negative pathways are they are a dynamic which is ongoing all of the time. And as I mentioned, the role of systems people who can take the systemic approach and apply systems thinking. Our job is to promote the positive pathways and to mitigate the negative ones. And this is essentially what we do every day in our discipline of systems engineering. Yeah, I'll just highlight it. So down here we're building relationships. Here we're enhancing perspectives and viewpoints and developing our knowledge. Here we're being distinct towards outcomes. We're doing design. We are identifying new know-how. And here we're putting it into practice in terms of the realization of these systems and the sustainment of these systems. Now, what I've done is I've taken a look at the different key performance indicators from Amar's work, and I'm not saying that this is perfect, but there's a very interesting relationship between what Amar is proposing and this general human activity system. So, if we just look at this one, for instance, you can see that in this area, we've got coordination systems, raw materials, product technologies, the diversity of products and experience, and the physical infrastructure, which is all contributing to, our know-how, which then feeds into, our governance, the interactions, the decision making, the mode of governance, the resource and expertise, and the span of governance. It's all in this kind of area. So it's just an interesting way of building, you know, relationships across potentially different ways of thinking and know-how. And you can do this across a lot of our practices, like project management and systems engineering. We can be taking a look at all of those different disciplines and working out how they all fit in this overall flow. And then we can start turning our project management and systems engineering into something which is, more based on theoretical models. Because there's a recognition in systems engineering and project management that largely everything that we do is heuristic in nature. And maybe it could be better if we apply system science to it. I'm going to look at one area and make it more explicit. I'm going to be looking at this particular area here, which is the technology, the technical area. Because this technical area, again, coming back to the theme of architecting and design, this is the area of architecting design in that overall schema. Architecting and design sits up in this space here. So what we have in the center is a couple of heuristic principles which have been developed by INCOSE, that's the International Council on Systems Engineering. So they have two principles in their overall framework. So systems engineering has an holistic systems view that includes the system elements and the interactions among themselves, the enabling systems and the systems environment, which is a very important principle from a systems perspective. Classically, within the systems engineering discipline, we've paid much more attention to the system of interest and less perspective, less consideration of the environment. And this is something that we are changing within our systems engineering discipline. The other thing that I can mention is systems engineering integrates engineering and scientific disciplines in an effective manner. So that connection with science, especially system science, is very important. On this overall schema, I've also included three really nice cards from the Waters Foundation. And the Waters Foundation have something called the Habits of the Systems Thinker. There are 14 cards, and they use these cards in schools to help children understand systems thinking and to think about systems. So here they've got recognizes that a system structure generates its behavior, observe how elements within systems change over time, generating patterns and trends, and identifies the circular nature of complex cause and relationships. The reason why I'm showing this on this particular diagram is because these heuristics in systems thinking are directly related to this particular context. Understanding trends, building dynamic models and simulations, um, helping to create handbooks, manuals, and courses, and helping to influence our planning, because these are the work products that help us to both mitigate the negative pathway and to promote the positive pathways. So these are work products of systems thinking and systems acting. And these products help us to resolve the pathologies. So, for instance, our architectures, our organizational structures, and what to achieve help us to explore potential and stop us from jumping to technology conclusions. And design, which is how to achieve something, supports the development of technologies and helps to address a lack of innovation. And again, when we look at this framework from Amar in terms of KPIs, again we can see a relationship between these different services and this particular space. So here we're creating coordination systems. We're taking advantage of material and raw technologies in the development of those technologies. We have obviously the process of technology. The diversity of our services and expertise is being developed, and we have input and output networks which obviously have a connection with making the dynamics explicit. So again, there's quite a nice correspondence between the two models, which is interesting to investigate. So I'm drawing to a close now. So here's the references. I'll make sure that the presentation is available to everyone, so you'll be able to go and look at some of this material. I'm just going to mention briefly, what we're doing in the ISSS. We're working to promote essentially a collaboration across the systems community. Our conference in July, which includes an online content as well as being physically present. The whole theme of the conference is about advancing together to promote practical outcomes for collaboration across all of these different areas. And these all relate to the hierarchy that I was talking about earlier. Influencing policy, shared working groups, joint promotion, sharing of capabilities, publications, research, education, professional development, methodology and tools, and also joint funding proposals on programs and projects. Because we believe that by coming together in a shared purpose, we can build a stronger, more cohesive systems community and create a greater impact on the world stage. So thank you for listening to me through the talk. Just one more slide in terms of advancing together. So this is, if you like, my overall vision for what we're trying to achieve and the strategy to get where. So by working together, I think that we can better leverage the assets of the systems community as a whole. We can reach out to systems people and organizations, understand the aims and challenges of others, foster collaboration with others to help achieve their aims, reinforce, adapt, and enhance our systemic capabilities. And by doing this, we will build a global community connected through systems theory, science, and practice. And essentially, if we can fulfill the needs of others, then we ourselves will be fulfilled. And that is the conclusion of the talk. And thank you for attending and showing interest in this. And I'd be very happy to answer questions you might have now.
Thank you so much, Gary. The lecture was absolutely fascinating. The way you brought together Amar's model and yours, it was very enlightening. I like the way that you began the discussion by defining and also the confusion behind definitions that I have found across the literature. Um, we sometimes talk in different tongues, and the exchange of ideas is incomplete.